Okay, so today we are going to go through the homework I've given you on aldehydes and on ketones. We're then going to do esters. We're going to look at how we name esters, what esters are, how we name esters, and how we draw them. But first things first, let's look at this particular compound. Now, who of you guys and ladies found this difficult? Be honest, put up your hands. All right, so most of you actually found it pretty challenging.
I was really confused.
Louder, up the volume.
I was really confused with the one branch that had
Okay. I purposefully put it. You know why? Because it's not a branch.
Oh, the other two.
You see, we don't, in NSC, we don't do branches with substituents in them. So therefore, it's okay. It's cool to be wrong in science. It means you've engaged. It means you've wrestled with it. It means you've tackled it, okay? So engagement is the name of the game. So longest chain must include the aldehyde group, all right? Then at this point, you can see there are three paths you can follow, but you follow the path where the iodine is a substituent. That leaves these two as methyl branches. Right, so looking here, we have got a methyl there. I use M for methyl. We have a methyl there. So we've got dimethyl. All right, what else do we have? We have an iodo here. Right, and we have a bromo. Let's use blue for halogens. We have a bromo here, right? And then what do we have? Then we have the aldehyde functional group. Now I'm going to talk more about that a little later on.
So isn't it like hexanol?
Isn't?
Is it like hexanol?
Anol means it's an alcohol. This is not an alcohol. Okay? All right, so let's take a look at this. So here is where our aldehyde functional group is. Now, let's just quickly talk about the aldehyde functional group because you are at times asked to draw the structural diagram. So the aldehyde functional group you represent as follows. It's C double bond O, H, and we like you to put an R in for the carbon backbone that would follow, the alkyl group that would follow. That is known as the aldehyde functional group. Right. If we talk about the ketone functional group, the ketone functional group looks like this. And we use R dashed and not R because these two alkyl branches could have different length chains. Are we clear on that? Okay. Some people will do it like this. That is also acceptable. Or your aldehyde group like that. That is also acceptable. I personally prefer those two, right? You will be asked this. However, these two functional groups both actually are containing the carbonyl function. Okay. Now, let's name this, right? So let's name this. So we go here. So now, Taylor, we count the number of carbons. 1, 2, 3, 4, 5, 6. Okay, let's count. 1, 2, 3, 4, 5, 6. So that is going to be, okay, is going to be hex and 1L. Now, do we need to put the 1 in there? No, we don't. Because by default, the first carbon is going to be the one where the aldehyde functional group is. So we're not going to do that. It's not wrong, but it's also not necessary. So we've got hexanyl, we've got that. Okay, now we need to number the carbons. Right, now we are going to number 1, 2, 3, 4, 5, 6. So let's do that. 1, 2, 3, 4, 5, 6. Right, so now immediately, now that we've got that, we can see that bromo is on carbon number 2. So this is 2 bromo. Right, we've got iodo on carbon number 6. It's 6 iodo. Have I missed a chloro? Ah, thank you very much. I've missed a chloro as well. So there is a chloro. Thank you very much. There is a chloro. Thank you, Trent. So that is, it's going to be 2 chloro. Right now, right, let's just see, we haven't missed anything else out. Now we've got dimethyl. Dimethyl. So it's going to be 5, 5 dimethyl, because both methyl groups are attached to carbon number 5. Are we okay with that? All right, yes.
So if we just read 5 dimethyl,
it's going to be marked wrong. You need to explicitly state that it's 5, 5. Good question. Good question. Yes.
When I checked the notes on Friday, it said like it has to be on the end. So what if you let's say numbered it the other way?
You would be penalized because it's on the end, and with the aldehyde group, that is the main characterization of this molecule. So this structure gets precedence, gets priority. You start numbering from there. Okay. These are all good questions. Okay, so now let's work alphabetically. We've got B, C, I, D. B, C, D, I. The D for di is not included. Okay, so first things first, we've got the bromo. So it's going to be 2 bromo. Done. Then it's going to be the C, 2 chloro. Done. All right, that's done. Then it's the iodo. It's 6 iodo. That is done. And then, last but not least, is the 5, 5 dimethyl. That is done. And then we put in the name of the carbon backbone. And this is an aldehyde, so that would be hexanyl. Now, I know that you're probably going to be shocked at this, but you are going to find that this, at a max, will be 3 marks. But more than likely 2. Okay. But with such a long one, probably 3. So it's not actually a lot of marks, but it's a fair amount of working out. I have no idea. I've moderated it, but I don't know. I can't remember. Okay, it's a fair amount. All right, so let's now move on to, and Trent asked how would we go about, we didn't ask this, but how would we go about representing this in condensed structural formulae? All right, so this is what we're going to do. We're going to start from the left-hand side. All right, so I'm going to start here, and I'm going to say, okay, I'm going to do it above here. We're going to start with CHO. So it's going to be CHO. Note, not COH. All right, this is not an alcohol. Right, this is not an alcohol. So it's CHL. Now, there you've got a carbon. You've got a carbon. This is this carbon. It's got a bromine and a chlorine attached to it. So we're going to put the bromine and the chlorine there. Reading it, we know that these carbons are attached to each other. This HO is an aldehyde group. attached to that carbon. The Br and the Cl are attached to that carbon. Okay, shorthand. So we've done that one, we've done that one. Now we come to carbon number 3. Can you see we've got CH2? All right, CH2. We've got another CH2. All right, so I'm going to write it explicitly, CH2. So we're now on carbon number 4. Then here now is where it gets interesting. Because this carbon here, carbon number 5, has got 2 methyl groups attached to it. This is where we use indentation. So I put a bracket, I put CH3, 2. You see that CH3 and that CH3 are attached to that carbon, right? This CH3 and this CH3, CH3, 2, but they're attached to that carbon, yes.
So for the CH2 and CH2, could you also put it in brackets?
Yes, we could have made the CH2 bracket CH2 2. I was going to do that in the next step. Okay, it's right. All right, now when it comes to this last one, it's going to be CH2I or CiH2, doesn't matter. All right, so tricky, thanks for asking that. Tricky. This indentation is very important, okay? This here, as Alan has mentioned, we could have taken these two and written it as CH2, 2. Are we okay with that? Notice that this is in the branch, CH2, CH2, but this can't be because it's a CH3. Yes, Josh.
Sorry, would that also get you like 2 marks?
That would be 2 marks, yeah. About. It wouldn't be 1, probably be 2. I would say on grade 10 level, to be fair, that should be 3 marks, as should this be on grade 10. But in matric, you're probably looking at 2 marks. Right, can I move on? Yes, Taylor.
Is this matric work?
Yes. Yes, it is. Yeah. All right, let's look at the next one. So the next one, we now have to look at the substituents. So if we look there, we've got here, we've got a chlorine, a bromine, a fluorine, and a bromine. We also have another 2 chlorines. So let me just change the color. We've got 3 chlorines, we've got 1 fluorine, and 2 bromines. All right? Our carbon backbone is going to be CCCCC to the right. Now, I purposefully constructed it in such a way that this looked like the longest chain. But we choose this one because it's got the substituent in it. So this becomes an ethyl group. Right, and notice that very, very, very importantly, there is your ketone functional group. So this is a ketone, right? So looking here, if we count the number of carbons, it's 1, 2, 3, 4, 5, 6. So this is going to be hex and own, all right? So now if we look here, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. If we count from left to right, that is hexane 3 own. If we count like this, 1, 2, 3, 4, 5, 6. If we go the other way, 1, 2, 3, 4, it would be hexane 4 own. We don't use the latter. We describe the descriptors, we number from left to right. 1, 2, 3, 4, 5, 6. Gives us the lowest number for where the carbonyl group is in the ketone. Are we clear on that? Okay. Now we can then go and number. Keep in mind that this is going to be an ethyl or ethyl group. It's got 2 carbons. So this is going to be ethyl or ethyl. I prefer to say ethanol, ethyl, ethyl, tomato. Okay, doesn't really matter. Okay, so now let's take a look here. This is ethyl 5-ethyl because it's from carbon number 5. All right, if we look at chlorine, we've got meth. We've got 1, 2, 3. So this is going to be trichloro, and it's going to be 1, 2, 3. No, it's not. It's going to be 1, 1, 2 trichloro. These two chlorines on carbon number 1. This chlorine is on carbon number 2. So it's 1, 1, 2 trichloro. Right. I'm a great believer in reductionism. I'm a great believer that you take a big problem and then you cut it up into smaller problems. So rather than trying to name this in one step, rather do what I'm doing and we're naming each of the components of it. And once we've got all of that, we then look alphabetically and we then write it that way. All right? So we've done the chlorines. Now let's look at the fluorines. So we've got 4 fluoro. See there, carbon 4, we've got fluoro. The bromo, we've got 4 and 6. So we've got 4, 6 dibromo. Bromine is on carbon 4 and carbon 6. It's dibromo. And then we've got 5-ethyl, and it's hexane 3-enol. 3-one. Now, have I missed anything out? Are you happy with what I've got? All right. Cool. Now, so let's work alphabetically. Bromine has got B. That comes first. So it's 4, 6 dibromo. That's done. We've got B, then we've got C. The tri doesn't come into the T for tri is not included with the alphabetical order. So it's going to be 1, 1, 2 trichloro. Okay, that's done. So we've done bromo and chloro. Then comes the ethyl or ethyl because that's an E. So there's the E. So this is 5-ethyl. And then we've got the 4 fluoro. And then at the end, we have the main backbone, the main part of the molecule. And that's going to be hexane 3-O.
So you forgot about the wait,
Okay, have I left anything out? Okay.
So do you think they'll give us the name and then we have to give the
We can give you the name and ask you to draw it.
Okay.
But I think it's more difficult to do this, to be given this and to interpret what the name is than to be given the name and to draw it.
Okay.
Yeah, you can go either way.
So would they give us a formula and ask for the name?
Okay, condensed structural formula. Yes. Then you need to expand it into structural formulae and then name it. They can, but remember, this is the first engagement you're having with organic chemistry, so we're not going to give you very difficult ones. When we get to the grade 12 exam, past exam papers, questions, you will see that sort of question. And my advice to you is when you practice for the exam, and I will give you the link, is you actually go to past exam papers and grade 12 papers and actually practice on them. Good question. Yes, Dick.
Are we still going to cover cycloalkene?
Probably not, because I need to work on esters. With the double we have tomorrow, if I get enough time to do it, will do it, but I would rather use that time in order to do past exam questions.
Because it does say that the cycloalkenes are on the exam. So
Who said that?
on the study guidelines.
They're not. We have decided that we're not including cyclo compounds in the exam. Right. I've seen that there are no cycloalkanes, alkenes. All right, so now quickly, if we look at the condensed structural formulae starting on the left, I'm going to make it CHCl2. CHCl2, this one is CHCl. I'm going to go a little bit quicker. All right, then here we've got, now can you see we've got CO. So it's CO. Then we've got CBRCF, CBRF. Then we've got CH. And then the indentation is CH3, CH2. And note that because it's indented, I put it in brackets. If I didn't put this in brackets, one could easily then read that it's part of the main chain. This is telling you that it's branched. And then here we've got CH2Br. Now, sure you know what my philosophy is. We practice harder than we need to play. This is considerably harder than what you're going to get in your exam. Okay.
So,
yes?
is this the standard of grade 12?
This is grade 12 standard, yeah. And we will practice hopefully tomorrow on some grade 12 standard questions. Yes?
For the first one, CL2, do not put a bracket on the...
Don't need to, because that carbon is going to be bonded to that carbon. That's the first bond. And then this carbon is bonded to the H. That's the second. And then it's got another two bonds, which are the two chlorines. Cool. Can we please move on? I would like to move to esters. And just want to quickly just check here how much time we have left. Okay. All right. Okay, so we've got a little over 15 minutes. I need to move on, so let's move on, please. All right. Yes. Yes, you may. All right, so the next homologous series we're going to work with are what we call the esters. Now, don't mix up esters with ethers. All right? Ethers we don't do in the syllabus. Esters we definitely do in the syllabus, and also one of the very, very important prac exams or practical investigations in grade 12 involves esters. Right, so let's look at the definition of esters. An ester is an organic compound. An ester is an organic compound formed when an alcohol reacts with a carboxylic acid. Right, so an ester is an organic compound formed when an alcohol reacts with a carboxylic acid. Now, what it lands up being is a compound that has part of the acid and part of the alcohol linked by means of the C double bond OO. And this we call the ester link. So the functional group for esters is known as the ester link. The homologous series, the family of these compounds, is known as the esters. Okay. Now the thing about esters is esters are sweet and they are used as flavorants and aromatics. They are used in the fragrance industry. All right. Esters are also oils. Now, have any of you ever been to a perfume shop in the Middle East? Okay, some of you have. Okay. They don't sell perfumes just like we buy them. They do, but the real perfume shops sell the essence. Do you know what the essence is? It's an ester. Have you heard of frankincense? Okay. In the Bible, they spoke about frankincense. Frankincense is an oil that had more value than gold. Frankincense, to extract frankincense was quite a procedure. Frankincense is an ester oil with beautiful, beautiful fragrance. Okay. So many, many years ago, I was in Cairo, and we went to a perfume factory, and I said, okay, I was going to buy my wife, some perfume, until I saw the price of it. I probably would have had to take out an excess on my bond because it was so expensive, because it's pure, right? And it's very, very expensive. So what we do is we dilute them with alcohols. And it's interesting that it dilutes in alcohol because of the fact that you'll learn in the next section on organic chemistry, which we do in grade 12, that this here is in actual fact a dipole, and the alcohols, the OH, forms a hydrogen bond with this, and so therefore esters can be dissolved in alcohol, certainly short chain ones. Okay, so when we look at the standard reaction for the formation of esters, it's this one, right? So an acid plus an alcohol produces an ester plus water. Now, we are not going to worry about the chemical equilibrium of it. We're not there yet. But what's very, very important is you need a catalyst. And so you need a hydrogen ion donator. So invariably what we use is an H2SO4, a strong H2SO4 acid. H2SO4 is a strong acid. And this is the catalyst. Right. So this is the standard solution, standard chemical reaction. And this process is known as esterrification, the formation of esters. Esterrification. Now, the best way to work with esters on school level is to draw the structural diagrams. Okay? So what we're going to do is we are going to produce an ester from these, apologies. We are going to produce an ester from methanol and from propanoic acid. Okay? These are the two, this is the alcohol molecule and this is the carboxylic acid molecule, and they are going to react. So I'm going to first and foremost draw the propanoic acid. So it's going to be meth-eth-prop. Okay. We're going to have C double bond O, OH, C double bond O, OH, and then 1, 2, 3, 4, 1, 2, 3, 4, filled up with hydrogens. Always a good practice when you're drawing to use the circle test around the carbons. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and oxygen has got a valency of 2, 1, 2. Then I'm going to draw the methanol, but I'm going to draw it in flipped around. I'm going to draw it like this: H, O, C, H, H. All right, I'm going to draw it like that. So this is propanoic acid. This is propanoic acid. And this is methanol. Okay. Now, the reason why I draw it like this is because when these molecules collide, an H, two H's, and an oxygen are going to be removed. Water is going to be eliminated. Very, very important. Please take note. Okay. Oh, you're writing on there. Okay. So water is going to be removed. So what happens when they collide, and next year you'll do collision theory, in order for two or more molecules to react, they need to have an effective collision at the right energy and at the correct orientation. So when these two collide, something interesting happens. Now, alcohols are actually acids as well because they can donate a hydrogen. This is explicitly an acid. We call it an acid. Now, we haven't done acids yet, where we've worked with the Bronsted-Lowry model, where an acid is a substance that is a proton donor or hydrogen ion donor. But we will get to that. So what happens is the following. This hydrogen here from the alcohol and this OH from the propanoic acid gets eliminated. So if we look at this reaction, we get water that comes out, so it's OH, H. If you go to university and you study chemical reactions on second year level, you'll deal with what they call mechanisms. There's a particular mechanism to this type of reaction, which is beyond the scope of the syllabus. Right. If you're really interested in it, I suggest you speak to Mr. Himon. He is a chemist who is very, very familiar with the mechanism of esterification. I'm a physicist, I'm not. So we use the recipe that in the collision, the hydrogen from the methanol comes off and the OH from the propanoic acid comes off. Now what is formed? What is formed is the ester. So I've drawn them specifically in different colors. So this is the 3-carbon structure from the propanoic acid is still there. So you see we've got the C double bond O from the carboxylic acid, but now we have the O and the CH3 from the methanol, right? And this water has been eliminated. And so the way we name this is as follows. And I will talk more about this tomorrow. This section here is a methyl structure. So this is known as methyl or methyl, right? And this structure in chemistry, if this is meth-F-prop, this is the propanoate structure. I'll talk more about that tomorrow. It's got the similar structure to the propanoate ion. So this is called methyl propanoate. So this is propanoate. You can put these together or you can leave a space there. I don't think it matters. All right. Now, this is the way we name esters. All right. I would like you, please, to do the following for me. I would like you to do the following for me. I would like you to do methyl methanoate, methyl propanoate, ethyl butanoate, propyl ethanoate, and butyl propanoate. But I'm going to help you. The second part of the name is the carboxylic acid. The first part of the name is the alcohol. So when looking here, the carboxylic acid that you're working with is methanoic acid. And the alcohol is going to be methanol. So coming back to these two molecules, what happens is that the hydrogen from the alcohol gets removed, okay? And the OH from the carboxylic acid gets removed. And what is left over is methyl propanoate. And there is your ester link. And I will pass this around. Thank you very much, ladies and gents. This is your homework for tomorrow, please.